Jenny told me 19 before she gets right now. She's like,
I think 15 is pushing it.
Yeah.
All right, so we're going to go to the notes section out here, and we're going to talk about what's here in chapter 1. Also, if you would go ahead and write your name on here and pass it around. I have 2 columns because there's a lot of people, so if you can fit all that in there, that'd be great. And yeah, that should work. So, yes. What are we actually doing? Well, we're doing statistics. Yeah, sure. But statistics is not the same as math. When we talk about doing math, there are certain characteristics of numbers that we get in this situation, which are not the same as what happened when we do statistics. So let's say I have this. What happens in your mind when I write this up on the board?
Both sides divided by 5.
Then what?
Divided by 5.
Okay. I'm going to close this over here. If I were to do this same problem 2 years from now, and if I do it correctly, will I get the same answer? Okay. How many of you have studied Babylonian history? What? Not a lot of Babylonian historians. The Babylonians were doing this same kind of problem 6,000 years ago. They used clay tablets with little chisels, and they make little marks, and they did problems like this. And they do trigonometry and other stuff. And they complained about their homework, and the teachers complained about their students, and vice versa. So it's nothing really different. If you did this same problem 6,000 years ago, you'd get the same answer. If you want to do this problem 6,000 years from now, you will get the same answer. But that's not what happens when you do statistics. What is the average purchase amount per customer at Quick Trip? How often does that number change?
Daily. Hourly.
a minute.
By the second.
All the time. Okay? Because as soon as somebody buys something, it changes that number. For the Quick Trip that's nearest my house, is this number the same as it was a year ago? Is it going to be different a week from now? Do you know what that number is going to be? Is it possible to know that number? No, you can't know what people are going to buy, even 5 minutes from now, much less a week from now or a month from now. This number is constantly changing. This number never changes. So when we do problems in statistics, the most important thing about statistics is this idea right here, variation. Numbers always change. And so we cannot expect that the answers we get in statistics will look like the numbers we get in regular math. They won't. There's another thing that's really important, though, about this. Nobody cares about x equals 3. The fact that x is equal to 3 in this problem doesn't make any difference to anybody, and it won't 6,000 years from now either. How important is this number?
It's important to Quick Trip.
How important is it to Quick Trip?
Probably really important because it keeps the business going.
It keeps the business going. How many businesses have gone out of business in La Crosse in the past 12 months?
12 months.
Can you name any?
Shopco,
Shopco,
Payless,
Payless,
Burgers,
Herberger's,
Macy's,
Macy's,
Sears,
Sears.
Mall.
No, I went to the mall just a couple weeks ago and it was fun for a while. Burger Fusion.
Technically, they still have a store in downtown La Crosse.
That's correct, but they're not up in the mall.
Rocky Rococo's closing the mall. That was bad.
Anybody know Oz Pasta?
Yeah.
It's not there.
That's a smoke shop.
Gander Mountain closed.
Gander Mountain closed. Then they reopened, didn't they?
There are stores.
They. If those businesses had this information and they were able to act on it, maybe that would have made a difference for them. But economic forces being what they are, maybe not. But the fact is, this number is really important. And a lot of places would need to be aware of that in order to know whether it's even worth being a business. Toys R Us, right? So these numbers, when you say, how much are people actually buying at my store? That makes a real difference. Nobody cares about x equaling 3. But the fact of the matter is, there's no way you can know the answer to that second question of a week from now, 2 months from now. Nobody knows the answer to that question. So here's an answer that anybody could figure out and nobody cares about. Here's an answer that's impossible to know that people really care about a lot. So what we have to do, if we're going to use statistics, we have to be able to understand that exact answers like this aren't very important. What's more important is that we have tools to understand these kinds of numbers instead of knowing exactly what they are. We need to understand them, not just get a number. A number by itself is relatively meaningless because the numbers constantly change. Variation means that they are not exact. And they won't ever be. They will always change. And since they always change, we cannot focus our attention on getting the exact number. That would not work for us. So then what we have to have here, in order to do statistics, we have to have context. We have to be able to understand whatever numbers or anything else that we get. We have to put it into relationship with other ideas. Now, in order for this to happen, then I want you to get 3 things in mind. The purpose of statistics, definition of statistics. And the process of statistics. Now, I've organized things a little bit differently than what I have in the notes. But these are things that I want you to know. And my goal is to ask you this question, the purpose of statistics, every day from now until August 15th. The purpose of statistics is data-driven decisions. What do we mean by data? We mean measurements of some kind. So we want to be able to make decisions based on some kind of measurement. When we say, what is that? We have trends, information, and what to expect. And statistics, it's kind of strange because it's kind of at the boundary line between mathematics and philosophy. Because what you have to do is understand why you do things, how you do things, what does it mean to have information. All that stuff is all tied in with what statistics is about. What happens when you walk into a doctor's office and say, I have a pain in my left arm? What kind of questions? Okay. How long has it been hurting? What's it on a scale of 1 to 10? What would happen if the doctor would say to you, I want you to put ice on that injury, and I want you to take ibuprofen? Would that seem reasonable? Why not? Okay. So how does the doctor know how much ibuprofen you should take?
Height and weight.
Height and weight? Medical history?
Amount of pain.
Okay. Is the doctor sure that that's going to make a difference?
Well, that's where to start.
Okay. How is it that they don't know what they're doing? How is it that they don't know that this is going to work?
Every situation is different and everybody's body reacts differently.
Okay. Do doctors know that?
Hopefully.
Hopefully. They know that people are different. They're going to react in different ways. So how do they know what's going to happen when you take that medicine? Well, that's what to expect. They've done research, or other people have done research, which have said, if you take this stuff, then you're probably going to feel better. And so then that information, or a trend, if you want to say cause and effect, these are things that people have actually done research where they say they think they know what's going to happen, but they don't know for sure because these things are not exact. Everybody's different, so they don't know exactly what's going to happen, but based on research and data-driven decisions, they say if you take this stuff, you'll probably get better. Now, in ancient cultures, they would do different herbs, right? They would give people stuff and would cause them to do things, and they would say, okay, that's what happens when you do that. And so then they'd try other stuff, and they'd put them together. Now, supposedly, we have a different system where it's not just grabbing things off of tree branches, but we're actually doing like chemicals, right? But a lot of those chemicals are based on things that have been found in the natural world around us, which actually make a difference. And people have experience and they know what to expect when you do that. Well, how can we make that work in statistics? How do I know what to expect at Quick Trip in the next month in terms of sales trends? How can I use statistics to predict that? How could I use something like this? If I find out that 30% of children in La Crosse have had a family member in the hospital. If I know that number is higher than it was last year, maybe there's something I should do about that. But I can't know what's going on until I measure it, until I know what the data is. Then I won't necessarily know if that's going to be affecting the children in the cross or whatever. So I can go out there and I can measure something, and I can then maybe use that information to tell me things about what I need to do or how I can change things. But it's always, there's always this amount of variation. So in terms of making this happen, I have to have context, which means I have to have experience. Experience gives me context, which allows me to make good data-driven decisions. I cannot make a good data-driven decision simply by using statistics. I have to have experience to tell me if it's important or not. What would you say if I told you that in the United States there were 240,000 jobs created in February? Would you consider that to be a good or a bad number?
It's not great because when you look at how many people there actually are, that's really not that many jobs.
Unless in March it was 10,000. If we compared 10,000 to 240,000, well, March looks really bad. February now looking pretty good, right? How many jobs does the United States normally create in a month's time? I don't know the answer to that question. So I don't necessarily know if 240,000 is a good or a bad number unless I have some context to know how much in my experience it's happened. Let's see. Jobs created per month. That's not really helpful. Jobs in La Crosse. Okay. $312,000 created in December. Do I have a chart, maybe? Oh, here we are. So 250,000. Well, that'd actually be pretty good. You know, it's kind of the high end. But I don't know that until I have some context, unless I have some experience. And certainly when you say there's 300 and some million people in the United States, 250,000 doesn't seem like a whole lot, right? But in order to understand these things, we have to have some kind of experience with them. What if I were to say to you, my sodium level is 150? I'm not a doctor, so I don't know what 150 would be, right? Good, bad, indifferent, I'm not sure. Just knowing numbers doesn't tell you what's important. So when we're doing statistics and we want the numbers to tell us something, we have to be able to have context based on our experience. We'll talk more about that next time as well. But the definition of statistics, there are three things. There is collection, presentation, and decision. So if somebody says, oh, well, I need to know the statistics on this. Well, that involves three things. I would have to know what the numbers are. I'd have to find the numbers. I'd have to figure out some way to present them, and then some way to make sense of them to say, this is a good or a bad one. We will take maybe a half an hour talking about collection. We might spend a week talking about presentation, and we'll spend like 13 weeks on making decisions. Then when we say, what is the process of statistics? The process of statistics is using a sample to understand the population. Population. So that means you need to understand those ideas. What is a sample versus a population? A sample would be like 700 people surveyed. In Wisconsin. The population would be people in Wisconsin. A sample might be 45 epilepsy patients. And the population might be all epilepsy patients. And this kind of gets rough because most people have something in their mind where it's like, how can I know what everybody believes if I only talk to 700 people? And the fact is, there are mathematical reasons why we might say, if I talk to 700 people, I have a good idea of what everybody in the state of Wisconsin believes. But that depends on certain things, and we'll talk about what those things are. The fact is that a sample is not exact. Okay? A sample does not tell us exactly what the population has. If I talk to 700 people, you're right, I didn't talk to everybody. But if I do it correctly, then it's possible that these 700 people could give me a basic sense of what the population is going to believe.
So is this more math or research? Because what you're saying, this just sounds like research instead of math, which is
Right.
confusing me.
Okay, we start by talking about the research, and then we get into the math. Because this kind of stuff, when you look at it, then you're looking at the numbers that we have, and then you have to say, what's the meaning of them? And what is really important is that when you draw your conclusions, when you get down to the end of the problem, that you're able to describe your answer correctly. So when you get down to the end, most of the time, we will not just be saying this is what the sample is. We would actually be saying this is what the population is. And so in order to properly phrase your answer, you have to know, what is this process trying to do? What's our goal in doing it? So we have to start with that. Yes, we will get to plenty more math in the time later on. Okay. Other questions about what we have currently up here? Okay. So then, when we talk about this process of statistics and the fact that it has a lot of variation involved in it, then we have to be concerned with how do I choose a sample? How do I actually make this work? I'm gonna turn down the heat a little bit here. So I want to be able to choose a small group out of a larger group. And the mathematics of the situation normally require it to be a random sample. So if I want a random sample of, let's say, 5th graders, how could I possibly get a random sample of 5th graders in lacrosse? Any ideas of how that might happen?
School at the end of the day.
Okay, if I stand outside the school at the end of the day and I wait for 5th graders to show up, right? Well, actually, no, that won't work for me for a couple of different reasons. Any other idea?
You could reach out to the elementary schools
Okay,
to give them surveys for their students.
okay. If I want a random sample, what I would need to do, though, is to have every possible result has an equal chance. When we say a random sample, we mean that every outcome has an equal chance. Is it true that a raffle is a random event? If you have 400 raffle tickets, do they pick them out at random? Mariah, you say yes? Yeah, pretty much.
Yeah, because they.
What do they do?
And then they just pick a random one.
Yeah, there's no pattern to it. It's not like they look at them and say, okay, well, what's that person's last name, right, or anything. And it's not like they just, the one on top, they don't grab the one on top.
Right.
Hopefully, right? Yeah. Okay. So if you have some way of having a list of everybody and you somehow mix it up so that everybody's got an equal chance, that would be a random sample. So you might be able to do that if you had a list of all the 5th graders in lacrosse. And you have, like, you could either use a computer or something else to randomly pick 5th graders. But what if you're standing outside the school?
You're taking a chance of getting a 4th grader or a 3rd grader.
Okay, well, you're just going to say, hey, what grade, hey, what grade, you know. Then you get a
Everybody's
5th
has an equal chance then? That's one school versus.
Oh, so it doesn't work if you just go to one school, you'd have to go to all of them, right? Well, is there a possibility you might miss somebody? Yeah. What else?
Researcher biases, like you might only talk to like white children.
Oh, so you're not going to go up to somebody and ask them what their grade is if you don't like them. Maybe. Maybe they have like after school activities, so they're still in the building. They're not going to come out for another 2 hours. You don't know that, right? If you have a list of everybody and you're able to pick from that list at random, then that would be a random sample. A bad kind of sample is what we call convenience. If I were to ask the people in this room about your experience with calculators, why would that not be a random sample of Western students?
You're only asking this class, not the other math classes?
Okay, is there a possible difference between this class and other classes in terms of their use of calculators? Yeah? There might be higher level classes that have different kinds. There might be lower level where they don't use them at all. So if I ask you guys, that's not a random sample, but it's awful convenient, right? Because you're right here. I could just ask you questions about your calculators. One of the problems that comes in here is the idea of the internet survey. I don't know if you've ever seen them, but you go to some website and it says, what do you think about Joe Biden? And then you click on it. Why is that a problem?
Lower economic people probably don't have internet.
Okay, so internet access is not universal. Anything else?
Depending on the website itself might be biased to who goes there.
Okay, absolutely. If you have a website and the main kind of people who go there are a certain kind, you're not getting a general survey. You're just surveying people who like that website. You know, let's say it's Pinterest, right? So you got something on Pinterest. Well, not everybody cares about Pinterest, but yet there it is, and you're getting just those people on there. Or like a news channel. Not everybody looks at news channels. So the surveys that they have are just not good. They're just not. So basically, you can't really trust any internet survey because it's only people who are interested in that particular website who might click on the thing. Now, there are some other kinds of methods here. I'm going to put a maybe on here. What's called a cluster sample, where you randomly select a group. So like you have 500 hospitals and you have a list and you figure out, I'm going to pick 20 of those hospitals. And then you survey everybody at that hospital. Well, that's something. It has, you know, a little kind of random effect there. So there are some kinds of things where that can happen. One of them is called systematic. Where you have a specific pattern. Like you want to get opinions at festival and you pick every 6th person to come out. You don't pick everybody, but you pick every 6th one. And it's like, well, that's some way to kind of randomize your ideas, but it might not be the best. It's something. It has a little bit of randomness in it, but it's not like the real definition. Randomness says that every person has the possibility and it's all equally scattered. So the raffle thing where you put things in a bag, that's a good option. However, there are other problems that come in when we talk about doing sampling. And what we're going to talk about is problems of bias. What is bias? Basically, it's anything that affects the result. So you could have somebody who's doing the survey and they make their questions so that they sound a certain way because they want a certain kind of answer, right? They'll say something like, oh, well, did you know that Joe Biden has been accused of bad things? And then they'll say something like, did you know that Elizabeth Warren has won 3 Nobel Prizes? I don't even know, but something, So they're going to put stuff out there, and it's going to sound really bad on one side and sound really good on the other side. So you're like, oh, wow, I didn't know that. No, I hadn't heard about that. Oh, really? They're not actually surveying you. They're pretending to take a survey, but they're actually trying to tell you stuff, right? And make you think a certain way. So that kind of thing happens out there. And then we have what are called confounding variables. This is one of the most important things in statistics. And it's not very common to people think about. Confounding variables. And that's any measurement that can affect the result. And this one I just found, and so I'm really happy about it, so I got to tell you. Okay. What can we say about people who consume alcohol and their relative health? Jordan, you got an opinion here?
What?
About the health of these different categories of people.
Well, people who consume high amounts of alcohol are probably, their liver probably really isn't.
Okay, so you're going to say bad or poor health?
Or
Poor health for the high consuming. All right. Any other opinions, Jordan?
moderate, I mean, probably pretty normal people.
Okay, so
Okay, health.
okay health-wise?
Yeah.
Now here comes the $1 million question.
They're probably pretty healthy, probably pretty great.
I'm sorry?
Spectacular.
You're wrong.
Oh, no, because wine is actually really good for you, like red wine. So, poor.
No, but wait a minute. I heard people laughing when you said that.
Like it could be from something else that just because they're not consuming alcohol, they could have something else that is, and then have bad health.
What? No, she just said that red wine was really good for you. And then everybody laughed. What do you think, Jordan?
About what Maggie said?
Yeah. Well, you don't have to answer.
Yeah,
All right. You can say pass.
pass.
That. Somebody had a hand up, but I wasn't sure. Yes.
I was just gonna say, like, maybe they don't consume alcohol, but they like eat fast food for every meal every day.
Okay. It's possible. But is there something that we could say that would be true about people who don't consume alcohol in terms of the reasons why they don't? That might be because of poor health, right? So there might be people who consume no alcohol and have poor health because they can't have alcohol because they're taking some kind of medication. Okay? Anything else?
Minors.
Minors? Nah, we don't talk about.
I mean,
No.
like children, not teenagers.
Right, but I'm saying, no, we're gonna leave minors out. We'll talk about that later. But, okay, right now, not just regular adults, quote unquote.
For moderate and high, how do they determine like what is moderate and what is high? Because that's gonna be different for different people. Some people consider high like 2 drinks and some people wouldn't consider high.
Yeah, well, we're just gonna have to trust them, they know what they're talking about. So if they're high and they're poor, then that would be like, as they get higher, it gets poorer. So then if you say like, I'm gonna measure people that have 2, 4, 6, 8, and then their health is gonna go down, then I would have some line in there, but I wouldn't necessarily say that I know exactly where that line is. Okay, so it's not just that I have some arbitrary line here, but I'm actually saying the more alcohol you consume, the poorer it's going to be at some level. Okay, so you're right, there's not a clear line there, but it's actually the fact that this is like a graded scale of highness and poorness. I mean, certainly, you would say that at some point, somebody's consuming so much alcohol it affects their health, right? Wherever that point is.
So I mean, like they didn't ask this survey then, and like, do you drink moderately or do you drink a lot?
Right.
'Cause
Yeah,
that's what I was thinking.
right.
If they asked the question like that.
Right, but it was more how much do you drink and then other measures of health. And they put those together. Yeah, that's right. Yes.
Is it kind of like an opinion based then? Like,
No, but this is, yeah, it would be more if they had asked the question that way, but they asked it as how much do you drink, how often, that like that. Okay? There's another.
Elderly who can't take care of themselves because of dementia or
Okay,
otherwise, so they're not offered or given the opportunity.
right, they don't have opportunity to drink if they have some other condition, right? Whether it's medication or just some hospitalization or whatever else, right? There is another thing though, which actually made a real difference when they put this variable into the mix. And it was socioeconomic status. How much money or wealth do these people have? Okay? If somebody is barely scraping by, they're not going to spend a lot of money on alcohol. In fact, they might not spend any because they just don't have the money for it. But those people also don't have money for healthcare. So then their health is also poor. So as it turns out, social economic status is a confounding variable here so that it actually explains the difference, not the alcohol consumption. The alcohol consumption is showing us something else, but it's actually that people who are moderate drinkers usually have more money than people who don't drink alcohol. And that's what actually makes the difference in their health. It's not the alcohol. Now, another thing that we need to understand here is the difference between 2 kinds of experiments, or 2 types of surveys. Observation versus experiment. Experiment. Observation is that you're just looking at things, right? But experiment is when you actually cause something to happen. People who were doing these studies who said that moderate drinking is associated with good health outcomes, they were just asking people what they actually did, right, in terms of drinking. But there was a study where they actually separated, I don't remember, like a couple of thousand people. And 1,000 of them, they gave them water, and the other 1,000, they gave alcoholic beverages. And they followed them for a few years and said, what's the health difference? And it turned out there wasn't any. So then when you say, if I do an actual experiment where I'm causing something to happen, then maybe that will give me an idea of the fact that this is the actual difference. The difference between these two groups is that I'm causing these people to drink alcohol, and it didn't affect their health. So then it doesn't make sense for me to say to people, oh, you should drink some alcohol for your health, because we tried it and it didn't work. Now that's different from what a lot of people have said, right? A lot of people, they said, oh, you know, moderate drinking, that means your health is good, so that means it's okay for you to drink in moderation. In fact, it's better for you. But they didn't actually make people drink and see if their health was better. They just assumed that this was the thing. When in actual fact, it's not that moderate drinking causes you to be healthy. It's that you have more money, which causes you to be healthy and allows you to drink as well. And that's a completely different conclusion, right? You should say to people, you should get more money. Ha, that's a good idea. Get more money, and then you can have good health, and you can drink occasionally. All right. But it's the money that made the difference. It was not the alcohol that actually made the difference. However, when we start giving people stuff that's causing things to happen, that can create some more problems. And what we're looking at here is what's called Heisenberg's principle. And this has nothing to do with Breaking Bad, anyway. Heisenberg's principle says if you measure something, you change it just by the fact that you measured something. And this actually came out of physics. But it's true in a lot of different ways. What happens if you say to somebody, I'm going to give you orange juice extra every day and see if you feel better? And you say to somebody else, I'm not going to give you orange juice every day, and I want to see if you feel better. Just the fact that you told them you were doing something makes them feel different, right? Let's say I made an appointment for you to wake up at 8 o'clock every morning and go down to my research facility and take 5 green pills every day. Would that change your life? Well, it would mine. I don't get up at 8 o'clock and go somewhere every day. So how do we know it's the getting up at 8 o'clock or if it's actually the taking of the pills? And it turns out this has so many different things, and you can read in your textbook about the idea of a placebo and about the double-blind experiments. We might talk about that next time. But the fact is, if you ever have a research study, the fact that you're making a research study is going to change the things that you're measuring. If you go out to a school and you say to a bunch of middle schoolers, tell me about your drug use, what's going to happen?
They're not going to tell you. They're not thinking of their parents.
Oh, so they're going to be scared to tell you anything because they're afraid of what might happen. Could the opposite also happen? Do you think that a middle schooler would write down on their survey that they take LSD when actually they don't? I used to be a middle schooler, and that sounds attractive to me. as a middle school? Sure. Yeah, I take heroin, LSD, crystal meth, mushrooms. What else you got? They actually did the research, right? They had one of these surveys and they came back to the middle schoolers and the person came in and said, okay, I'm from California. I don't know your parents. I'm not going to tell anybody, but I want to know more about your drug use. And the middle schooler says, I lied. I don't take drugs. And so then they found that that was somewhat common, okay, among middle schoolers. When you ask them questions, they just make stuff up. So how can you know about middle schoolers and their drug use? You got to watch them. Or maybe you actually need to get to know them. I know that doesn't sound very attractive to most people. I want to sit in a room with a bunch of middle schoolers and find out what they're like. But you really don't have a choice. If you want to know what's going on, you actually have to get to know the people, not just the survey. And there are so many things that have to do with this. If you look outside the window, you will see that it's a very nice day. If I were to give you a survey about this class, you would say, wow, it's such a nice day. I don't know about this class. I have to be inside. But what if it was a really stormy, gloomy day and I gave you the same survey? You'd be like, oh, the weather sucks. I don't like this class. So I can't win, right? If it's nice, you don't like the class. If it's bad, you don't like the class. All right, so these are the ideas that are going to be in this first chapter. And we'll probably talk a little bit about placebos and stuff. And if you run into anything, questions, please let me know. Homework set number 1 is due on Thursday, and then we'll start talking about chapters.
Yeah, you're right. Okay, so
Thanks.